Ever wonder how those like really complex software applications manage to stay organized?
Yeah,
Behind all the fancy user interfaces and stuff, there's a ton of code going on back there.
right.
Today, we're taking a deep dive into like this fundamental idea in software architecture, layered architecture.
Okay.
So get ready to explore how this pattern helps developers create like robust and maintainable software. It's going to be a fun one.
It's a classic pattern for sure, layered architecture, and there's a reason why it's so popular. It's like the blueprint of a well-structured building.
Hmm.
Each layer has a very specific job to do, and they all work together in a very controlled way. It's all about modularity. Makes software so much easier to actually develop and test and then manage later on.
Okay, I'm definitely intrigued. But before we dive into the why, can you give us like a simple definition of what layered architecture actually is?
Okay, so picture your application like a series of horizontal layers, right? Each one is in charge of a specific part of what the software needs to do. This structure ensures that each layer can be developed and modified independently without messing with the others.
So kind of like those lunch boxes with all the little compartments.
Mhm.
Keep your sandwich separate from your fruit salad so it doesn't get soggy.
Exactly. Each compartment has its own purpose, and everything stays neat and tidy. In layered architecture, those compartments are like distinct modules of code, each handling a specific responsibility.
I like it. Okay, so we've got these layers all doing their own thing. Can you break down like the typical layers we'd see in a layered architecture?
You probably already know these. The classic four: presentation, business, persistence, and database.
Okay, yeah, I've heard of those.
The presentation layer is all about the user experience, how they interact with the application. Think user interfaces and all the visual elements. Then you've got the business layer. This is where the core logic lives, all the rules that make the application tick. And then we've got the persistence layer, which is all about how data is stored and retrieved from the database. And finally, of course, the database itself, where all that precious data actually lives.
Okay, that makes sense. So how does a request actually move through these layers? Let's say I'm on an app and I'm ordering a pizza. What's the journey of that order, from my hungry fingertips to the pizza place?
Okay, let's follow that pizza order.
Okay.
You tap Order Pizza on your app. That's the presentation layer. That request goes straight to the business layer. That's where the app processes your order, checks if they have the pizza you want, applies any discounts, and calculates the total cost.
So the business layer is kind of like the brains of the whole operation, making sure everything's running smoothly behind the scenes.
Exactly. But now the business layer needs to store that order information somewhere, right?
Yes.
So it sends the data over to the persistence layer, which is like the go-between with the database. Think of it as the filing cabinet for all those pizza orders.
Okay.
This layer formats the data nicely and sends it to the database for safekeeping.
Got it. So my pizza order is sitting there in the database waiting.
Mm-hmm.
But how does the pizzeria actually see that order and start making my pizza?
So now the flow might actually go in reverse. The pizzeria's system, which probably also uses layered architecture, sends out a request to fetch any new orders. That request goes down through its own layers, hits the database, and grabs your order info.
Oh, that's cool. So the layers are working together both ways, placing and retrieving orders. That's pretty neat.
It is, and what's really neat is that each layer only needs to communicate with the layers right above and below it. It doesn't need to worry about what's happening in those other layers.
Right.
And this isolation makes it so much easier to maintain and update the software down the line.
That sounds super efficient. But I'm curious, is this strict like up and down flow always the case? Or are there ever situations where a request needs to like skip a layer?
That is a great question. And it brings us to the idea of what we call closed versus open layers.
Okay.
The scenario you described, where each layer can only talk to its immediate neighbors, that's what we call a closed layer architecture. And it's the most common way to do things because it really enforces a strict separation of concerns, which is crucial for building software that's, actually reliable.
Closed layers. Got it. So what about these open layers? When might we need to like bend the rules and let a request jump the line?
Okay, let's say you have some functionality that needs to be accessed by multiple layers. A good example is logging.
Okay.
You might want to log events that happen in both the presentation layer and the business layer, right?
All right.
Instead of writing the same logging code in each layer, you could create what we call a shared services layer.
So it's like a central hub for all those common functions.
Exactly. And to do that, you'd make the shared services layer open so that both the presentation and business layers could directly access its logging functionality. without having to go through the persistence layer.
Right.
This can definitely streamline things and make things more efficient.
Okay. But I'm sensing a but coming. What are the downsides of opening up a layer like that?
Well, the main concern is that it can create dependencies between layers.
Okay.
If you change the shared services layer, now you have to think about how that might impact both the presentation and the business layers.
Yeah.
And that can definitely make maintaining the software a bit more tricky.
Right. So it's a bit of a balancing act then, right?
Exactly.
You gain some efficiency by sharing functionality, but you might also introduce more complexity because now those layers are more connected. So how do developers figure out when to use closed versus open layers?
It really comes down to carefully weighing the pros and cons based on the specific needs of the application. Sometimes, the benefits of sharing outweigh the risks of those dependencies. Other times, that strict isolation of closed layers is really important for keeping the software stable and easy to work with.
This is making a lot more sense now. We've covered the basics of layered architecture, the typical layers involved, and even got into the details of closed versus open layers. I'm sure there's more to this story, though, right?
Oh yeah, definitely. We've really just scratched the surface here. Stick with us. There's lots more to discover as we explore some potential pitfalls and things to watch out for when you're designing and implementing layered architecture.
Okay, sounds good. All right, so we've got a good foundation now. We get the basic idea of layered architecture, why those separate layers exist. But you mentioned some potential pitfalls. Like, what are some common traps that developers might fall into when they're working with this pattern?
Yeah, so one thing to definitely keep an eye out for is something called the architecture sinkhole anti-pattern.
Okay, that sounds ominous.
It is a bit of a mouthful,
Yeah.
but basically what happens is requests end up flowing through the layers without any substantial processing happening in each one.
Mm.
They just kind of become pass-throughs,
Yeah.
adding overhead without actually doing much useful work.
Okay, so it's like those annoying phone menus where you keep pressing zero go just to try and get to an actual human being.
Exactly. Yeah.
Like the request is moving, but it's not actually getting anything done.
Right. Can you give us a concrete example of how this might actually happen in software?
Sure. Think about a system where you're just trying to get some basic user data, like a name or email address.
Okay.
And the request has to go through all these different layers that basically just pass it along.
Right.
Each layer might add a tiny little bit of processing time, but when you multiply that across a ton of requests, that inefficiency starts to become a real problem, and the application can feel slow.
So it's kind of like death by 1,000 paper cuts. It's not a big deal on its own, but it adds up over time.
Right, exactly. How can developers even tell if they're falling into this architecture sinkhole?
A good way to think about it is that 80-20 rule. It's normal to have maybe 20% of your requests just be simple pass-throughs.
Okay.
But if you see that number getting much higher, way higher, that's a sign that something might be off.
Okay.
You might need to rethink your layers or find ways to combine some of the logic.
So if most of our requests are just zipping through the layers without actually doing any real work, that's a sign that we might need to go back to the drawing board.
Yeah, potentially.
What are some ways to actually fix this?
Well, one thing you can do is take a hard look at each layer and ask, do we really need this layer, or can we merge its functionality with another layer? It's all about making that flow of requests as streamlined as possible, making sure every layer has a clear purpose and is actually adding value.
Okay, that makes sense.
Yeah.
Now, the source material also mentioned this idea of layered architecture sometimes leading to monolithic applications.
Right.
I'm guessing that's not really a good thing these days with everyone talking about agile development and cloud computing.
No, not really. You see, monolithic applications are kind of like these giant self-contained units where everything is really tightly connected.
Okay.
It's like baking this huge cake that you can only bake and serve as one big piece.
All right. I like where this analogy is going.
And while that can work fine for smaller applications, it can become a real headache as things get more complex.
So what's the problem with a giant cake? I mean, who doesn't love cake? When do things start to fall apart?
Well, imagine you want to make a tiny change to this giant cake. You'd have to rebake the whole thing, even for a tiny tweak.
Yeah.
And monolithic applications run into the same problem.
Yeah.
They can be really hard to update and even harder to scale. In today's world where things are moving so fast and you need to be able to constantly update and deploy your software, this lack of flexibility can really hold you back.
Got it. So if we're working with layered architecture, how do we avoid accidentally creating this, monolithic monster? How do we keep things modular and flexible?
That's where the design and the planning phase become really crucial. You need to pay close attention to how those layers depend on each other and try to make each layer as self-contained as possible.
Hmm.
It's like finding that balance between modularity and integration.
So it's not just about the layers themselves, but also how they actually talk to each other and depend on each other. This is kind of reminding me of that conversation we had about closed versus open layers. Is there a connection there?
Absolutely. If you have way too many open layers, all interconnected, you're basically just asking for a tightly coupled monolith.
Right.
It's like those headphone wires that get all tangled up.
Yeah.
Closed layers with their stricter boundaries can definitely help prevent that from happening.
This is really helpful. It seems like designing good layered architecture is all about hitting that sweet spot between keeping things separate and making sure they can still work together well. Are there any other things that developers should be thinking about? We've really covered a lot of ground here, from like the basics of layered architecture to those potential pitfalls like, architecture sinkholes and monolithic structures. But I guess I'm still wondering, is layered architecture still like relevant in today's world? With all the talk about microservices and cloud native architectures, is this classic pattern starting to get a bit, outdated?
That's a really good question, and one that a lot of developers are thinking about these days. And while layered architecture is still a very powerful way to build those robust and well-organized applications, it's not always the perfect solution, especially as those applications get more and more complex and we start dealing with all the demands of those cloud environments.
So it's not a one-size-fits-all kind of thing.
Yeah.
Are there certain situations where layered architecture might actually be a better fit than those newer approaches?
Oh, for sure. For applications with a clear separation of concerns and like a fairly straightforward flow of logic, layered architecture can still be a fantastic choice. Gives you a really solid base to build software that's easy to maintain and can grow with you, especially if you're new to thinking about architectural patterns.
So it's a good starting point, but as your application kind of grows up and things get more complicated, other patterns might be a better way to go in terms of flexibility and scalability. Can you give us like a quick rundown of how those other architectures like microservices are different from the layered approach?
Yeah, so microservices, for example, they take a totally different approach. They break down an application into smaller, independent services that all communicate with each other over a network. So each service can be developed, deployed, and scaled completely on its own, giving you way more flexibility and agility compared to a monolithic structure.
So it's like switching from a giant cake to a whole bunch of little cupcakes. Each cupcake can be like customized and enjoyed on its own.
Yeah, that's a great analogy.
That sounds really appealing in today's fast-paced world, but I imagine there are trade-offs here. Like, what are some of the challenges that come with microservices?
Yeah, you're right. There's no such thing as a free lunch. Microservices definitely introduce their own kind of complexity when it comes to managing those distributed systems, making sure the data is consistent across all those services, and handling all that network communication. It's a whole different set of hurdles compared to a more centralized layered architecture.
So it really comes down to finding that right balance.
Exactly.
Choosing the right architecture depends on a bunch of factors,
Right.
right? Like the size and complexity of what you're building, the skills of your development team, and like the big picture business goals. Is there like a simple rule of thumb that developers can use to help them decide?
If you're just starting out with a relatively straightforward application, layered architecture is a great place to begin. But as your application grows and you need more flexibility and scalability, you can always explore those other options like microservices. It's all about picking the right tool for the job at hand.
This has been a fantastic deep dive into layered architecture. We've explored its strengths, its weaknesses, and where it fits in the big picture of software architecture. Any final words of wisdom for our viewers out there who are busy building and working with these complex software systems?
I guess I would just say, remember that there's no magic bullet when it comes to architecture. The important thing is to understand the trade-offs, really think about what your application needs, and pick the pattern that best fits your goals, and never stop learning. The world of software architecture is constantly evolving, so stay curious and keep exploring new ideas.
That's great advice. Thank you so much for sharing all your insights with us today. You've given our listeners a lot to think about. And if you enjoyed this deep dive, be sure to subscribe to the Topictrick YouTube channel for more great content just like this. Your subscription helps us bring you even more deep dives into this fascinating world of tech. Until next time, keep coding and keep learning.